All right, algebra people. Today we're going to be looking at solving exponential functions. We're going to do this two ways. The first way is going to be graphically, which I'm sure you're going to love. And the second way is going to be analytically, which is a little bit more stressful, but we're going to try and keep it basic. So let's start off with graphically. We've got this exponential equation right here. 2.5x to the third power, and then 6.25. Let's take a look at that. We're going to graph, and then remember the key for this is to graph the left equation, and then graph the right of the equation, and then look for an intersection. That's all we're going to do. Let's get to Desmos, and let's graph y equals 2.5 to the power of x minus 3. Now take a look what happened here, because this is kind of typical. The minus 3 is no longer in the exponent. So I got to make sure that that minus 3 is up there in the exponent part. So I think what I need to do is put parentheses around it. So x minus 3, so that it'll stay up there. All right, so that works. The next one is going to be y equals 6.25, if I remember that correctly. Perfect. And then we just need to look for the intersection. There it is. Intersection point 5 and 6.25. So looking at this equation, remember we have 2.5x minus 3. So what we were looking for here is actually the x-coordinate. And our x-coordinate is x equals 5. So that's our solution. I think you're going to love solving things graphically. I know you liked it last chapter, and this chapter it's basically the same thing, just different looking equations. Okay, and let's see about graphing. Let's see this, solving these graphically. These are not anything more difficult than what we just did. So let's try and grab a particularly nasty one. Oh, let's get this last one, letter I. Okay, we got 2 to the x minus 2. So on my Desmos, I'm going to say y equals 2 to the power of, and I'll learn, I'm going to put an x minus 2 in parentheses so it stays up there in the power. And then the other side of this is 3 halves x minus 2. So here in Desmos, we'll do a y equals 3 halves, 3 over 2, x minus 2. And nicely here, this shows you that there are actually two places where this happens, at x equals 2 and x equals 4. And let me tell you, it doesn't get much more nastier than equation I. I mean, that's an equation that's enough to give you fits, really. So we got two solutions. We've got x equals 2 or x equals 4. And this is something that you can do as an Algebra 1 student that even my calculus students, they can't solve this one very well. So, knowledge for you. You can solve exponential equations. You can solve practically any equation graphically. So let's get to this communicate your answer. Let's get to this word problem here. A population of 30 mice is expected to double each year. The number of mice in the population is given by this equation right here. And then in how many years will the population will be equal to 960? So we're basically solving when is P equal to 960? When is the population equal to 960? And then we also see right here that the population is given by this equation, P equals 30 2 to the n power. And my equation also has a P in it. So I can substitute that equation into, I can substitute the equation for P into P equals 960, and I get something which I can solve graphically. The first equation I'm going to graph is 30 2 to the x power, And I have to use x because I'm graphing and my calculator or my Desmos doesn't know how to calculate or graph for an n. And then the second equation I'm going to graph is y equals 960. So let's take it over to Desmos. We'll just type in our equations. Y equals 30 parenthesis 2 to the x power. Okay, that looks good. And then the next one, y equals 960. And I say, what happened here? I don't see that second curve. It looks like it's supposed to be green, but I don't see a green line. And then you realize, this is 960, and I'm only at 40 here. So I gotta get up to 960. So I'm going to go to Graph Settings, go to Y-axis, and change this number to something bigger than 960, maybe 1,000. All right, so now that I'm at 1,000, I can see that there's my green line where my green line and blue line intersect. And that's right over here at x equals 5. Take this back over to my student journal. My answer, n equals 5. Now, exponential equation, we already talked about what that looks like. An exponential equation is of the form y is equal to a multiplied by b to the x power. And that's my exponential equation. So let's move on over here to core concepts. So if two powers have the same positive base and they are equal if and only if the exponents are equal. And I'm going to highlight just one part of this right here. Exponents have to be equal. So we're going to take a look here in numbers. If we've got 2 to the x equals 2 to the 5th power, that means x has to equal 5. And it should kind of make sense. If two things are equal, all the parts about them have to be equal. And that's going to help us solve exponential functions algebraically, which is, I'm sure, what most people get taught, but they probably don't learn it very well. Don't forget that the graphical method is never going to fail you. So if you need to double check your work, go to the graphical method. Can't hurt at all. So let's see where else this will take us. All right, so now we're at extra practice. It says to solve the equation. Let's take a look at number 1. We notice that they have the same base, 3 and 3, but the powers are kind of different. This one's 4x and this one's 12. And what that says to me is, since they have the same base and they are equal to each other, that means the powers have to be equal as well. So 4x has to equal 12. So x has to equal 3. And that's all there is to it, really. Make sure they have the same base, and then the powers are equal. Look at number 2. We've got the same base already. They're both base 8. So that means that the powers have to be equal to each other. So x plus 5 has to equal 20. Let's solve that. So the two powers have to be equal to each other. I'm going to subtract 5 from both sides of the equal sign. And that tells me that x needs to be equal to 15. Okay. The easiest problems are pretty easy. Let's do another one of these. How about number 5? Now this is not an easy problem because notice we have 4 to the 2x plus 11 equals 1024. So we've got to find a way to make these go to the same base. So this should be 4 to the power of something, and I want to figure out what that something is. And maybe the fastest way to figure out what that something is just to use some guess and check. Let's go back to our Desmos. And we're going to guess and check over here. So let's see. What's 4 to the second power? Okay, that's only 16. I need to get to 1024. So maybe a fourth power? Nope. 6th power? All right, that seems too big, right? I only needed to get to 1000, and now I'm at 4000. So maybe to the 5th power. Okay, that works. 4 to the 5th power is equal to 1024. Guess and check. So 4 to the 2x plus 11 is equal to 4 to the 5th power. And now that the bases are the same, we can make the powers equal to each other. So 2x plus 11 equals 5. Subtract 11. Divide by 2. And x equals -3. Okay, this was a difficult question. Don't be fooled into thinking that just because you're in Algebra 1, you can't get a difficult question mathematically. You know, a lot of people can't solve this equation to save their life. Let's try another one. Let's try 8. This is the first one that I think is going to be a little bit difficult. So let's take the approach that we did before. If we have 49 to the x minus 2, is that equal to 49 to some other power over here? So basically 49 to some power is equal to 343. What would that power be? Let's guess and check again. Over here on Desmos, let's do 49 to the second power, and whoa! I've overblown it. That's 2,401. And I only needed to get to 343. So that's a problem. There's no base here or no power that works. So the next thing I'm going to notice is 49 is actually 7 times 7. So we can re-express 49 as 7 squared, and so we get 7 squared to the x minus 2. And then using properties of exponents, that's the same thing as 7 to the 2x minus 4. Remember, power of a power means you multiply. So now I have a new base. So now I can ask a different question. 7 to the 2x minus 4 is equal to 7 to what power? So now I'll guess and check with 7. Let's check 7 squared. And I know that's not going to work. 7 cubed. And wow, that did it. 7 to the third power is 343. So I'll fill that in with a 3. Same base. So the powers need to be equal. Now it's just a regular algebra problem. So x is 3.5. So what we've seen is if we may need to re-express our exponents so that they have the same base or different bases than what we see here. Yeah, same but different. Maybe we should try another one. Okay, how about, now that's something different. Yeah, let's do this one over here. Number 10. My first preference is to keep everything to the same base, which is the smaller one usually. So we've got 9 to the x minus 4. Is this equal to 9 to some power to the 3x? Because I need to get this to be 81. So 9 to what power is 81? And thankfully I don't have to actually guess and check. I know 9 times 9 is 81. So this is the same thing as 9 squared to the 3x power. Now we're going to use properties of powers to say that this is the same thing as 9 to the 6x. And again, from here it's just algebra. If you've got x minus 4 equal to 6x, you just work algebraically. Same base, so the powers are equal. Now, algebraically, we're going to solve. So x is -4/5. Now we peeked ahead, so I saw this and I was like, this is a very interesting, thought this was a very interesting thing to do. We've got things in the denominator, but remember, you know how to deal with things in the denominator, because if the number's in the denominator, this is the same thing as a negative power. So now I need to figure out, is 512 a power of 2? 2 to what number is equal to 512? And notice how I kept the negative sign on the outside of the power. Let's figure that out. Do some guess and check. All right, so let's try 2 to the 4th power. Okay, that's only 16. 6th power? Nope. 8th power? No, I'm getting close, I think. 9th power. 2 to the 9th power is 512. So this right here is 2 to the 9th power to the -1 power, which basically says 2 to the -9 power is equal to 2 to the... All right, this somehow changed from a 2x to a 3x, or from a 3x to a 2x, to the 3x minus 1 power. Same base, equal powers. Just do your algebra from here. So x equals -8/3. Now for the rest of these, I'm just going to do one because it says to use a graphing calculator. And I feel like you guys got the graphing calculator action. So let's try number 20. We've got 7 to the -x plus 1. So that's going to be my first equation. Y equals 7 to the -x plus 1. Then my second equation is going to be y equals -4 to the x minus 1. So I'm going to try to type it into my Desmos pretty much exactly the same way that I see it here. So here we got y equals 7 to the -x plus 1. We got -4 to the x minus 1. And I don't see where these two graphs intersect. So I'm going to try and drag the graph around until I can see where that happens. Oh, well, this is an interesting development right here. Here's a black line representing -4 to the x minus 1. And here's a purple line. And it looks like they're going to intersect somewhere around there. So why don't I zoom into that and see, do they intersect? Oh, wow, look at that. We had to zoom in quite a bit, and we can see that these two graphs do not intersect at all. Okay, I'm going to show that zoom one more time just to see. Here's what the graph looks like. We're going to zoom in to where we think they're going to intersect, and we see no intersection at all. They don't intersect. So if they don't intersect, once we get here, there is no solution. So that's it for our look at section, what is this, 6.5, and we'll see you next time here. Algebra. Have a good one.